Well, hello and welcome, everybody. Thank you for coming today to science. It's going to be a fun one today. We're talking about products of a reaction, as you can see above my head. And really, it's just going to be kind of a review and an extension of the stuff we did last week regarding chemical reactions and thinking about the different parts that go into a chemical reaction, how a chemical reaction is different from a mixture or a solution, per se, and then thinking about some couple of different interesting things regarding reactions. You're going to need your science notebook and something to write on. No real must do, no data table today. Just kind of jot down some wonderings, jot down some ideas, what you notice about what's going on today. And then down here, I can use observational evidence to determine if a chemical reaction has occurred. And I can define chemical reaction, reactant, product, and precipitate. So, how do we know a chemical reaction has occurred? We saw a number of chemical reactions last week, but we want to be able to use our scientific brains and be able to take that claim and put it with some evidence. Something we saw, something we heard, something we, could be smelled if you were in the classroom, could be tasted if we were tasting science. We're not tasting science today. Or something we felt, something we used our senses for. Some piece of observation that we can tie to that claim, saying, yes, a chemical reaction has occurred, and here is why. So we're going to take a look at one. This one that we did last week. This is our citric acid and baking soda. So we remember this one from last time. So I've got citric acid and baking soda here in my cup, and then I'm going to add 50 milliliters of water. So right away, something happened other than just those things combining into a solution, right? If it were a solution, we'd be able to see our solutes dissolve, but something happened here. What happened here? Right? We saw bubbles. We saw fizz, some massive fizziness, right? So that is one piece of evidence that we can say, I know that a chemical reaction has occurred because when we combined the substances, there were lots of bubbles. A gas was released, is what we would say. And the difference between, you might ask, what's the difference between this and, let's say, opening a bottle of soda? Because that also has bubbles, right? That also fizzes, so is that a chemical reaction? Let's think about this idea of a chemical reaction, and I'll pull the word wall up here. Think about the idea of a chemical reaction, it's right there, when two or more substances are mixed together and a chemical change occurs so that new products or new substances are formed. When you open a bottle of soda and there are bubbles coming out of that bottle of soda, right? Did we combine substances in that case? Or did we really just allow that carbon dioxide gas that was suspended within our soda to be released, right? In the case of the soda, that would be the latter. In this case, there was no carbon dioxide that we added by itself, but as we can see, carbon dioxide bubbles are being released, right? If you had a soda stream at home or some sort of soda fountain maker at home, right? You're taking water, you're putting carbon dioxide into that liquid, okay? That's a little different than a chemical reaction where you're actually creating carbon dioxide using two other substances. And the cool thing and the interesting thing about chemical reactions is, remember back when we were making solutions and then we evaporated out the water from our solution to see what was left? For instance, we let me grab our salt and water here. So we added salt to a solution, or to water to make a saltwater solution. And then we took a sample of it and left it out so that the water could evaporate to see what was there. And we ended up with these really cool looking salt crystals. These kind of square looking salt crystals. I'm trying to get a good angle so you can see these really cool looking little squares here. Okay, this is still salt, right? But if we were to take this citric acid and baking soda solution that is now reacted, and we were to leave that to evaporate, would we be able to get the citric acid and the baking soda back out? Because a chemical reaction occurred, and actually at the atomic level, all the atoms in, baking soda, all the atoms in citric acid, they kind of mixed up and jumbled and reassembled themselves into new structures. There's no rewind button on a chemical reaction. You can't go back and put those things back together. I'll show you what I mean. So let's look at these crystals, because believe it or not, I did evaporate these out. So this was our citric acid. Makes these kind of round looking crystals here. Okay, there's our citric acid. And then here's our baking soda. Let me move the word wall so you can see them both at the same time. Here's our citric acid and our baking soda once they've been evaporated back out. Okay. There's our baking soda in the middle, and then there's our citric acid. I'm going to try and put it in front of my shirt. Black background helps. Okay. Now, if we were to take this solution and it hadn't have reacted, we'd be able to see both our baking soda and our citric acid in our evaporation dish. But let me show you what it looks like when we evaporated out that solution post-reaction. Looks like this. Really different, right? Doesn't look anything like our citric acid by itself. Doesn't look anything like a baking soda by itself. Okay, this is another piece of evidence that a new substance has formed. This is actually what's called sodium citrate. You don't have to know that, but it does make these cool little patterns. Kind of almost like little hairs coming off, and then there's little kind of lines in here. Really interesting stuff, the sodium citrate. So really an important thing to note, that there is no back button on a chemical reaction, right? It forms a new substance, and then that new substance is there, right? We have our carbon dioxide that's coming off in the form of bubbles. Where's that carbon dioxide going? Right? It's going off into the air, right? We can't grab all that carbon dioxide and put it back and do take-backsies, right? It's going to be different stuff, okay? Another thing I want to talk about with this is this idea of what's called conservation of mass. Last year, if you think back to last year when we talked about energy, we talked about this idea that energy doesn't just disappear and can't be just created out of nowhere, right? Energy has to be converted from one thing to another, right? When you eat lunch, for instance, your body then converts all that caloric energy in the food that you eat and puts it to use via, maybe mechanical energy of moving your arm up and down when you're doing a fist bump, right? Or could be in energy making your heart pump, energy making your lungs go, energy helping you fight off diseases, right? Same thing with our circuits. When we short-circuited and overloaded our electrical circuits, that extra electrical energy had nowhere to go. It didn't just disappear, so it turned into heat, which is why when we short-circuited with our batteries and our wires, it got real hot, right? And you could potentially burn yourself with that extra energy, okay? This is true of mass, right? When we make a chemical reaction like this, okay, the mass of this chemical reaction, the mass of all of these substances aren't disappearing. They're just rearranging into new compounds and new substances. Okay? And we're going to see that right now. So what I've got here, I've got two solutions. One is our calcium chloride. Remember, it was these little Dippin' Dot looking things that aren't Dippin' Dots, so don't eat them. Okay, we have our calcium chloride in water, and 50 milliliters of water. So if we take a look at our scale here, let me grab an empty cup so I can tear it out. There we go. So now the weight of the cup has been accounted for. So this is 50 milliliters of water and 5 milliliters of calcium chloride, making 54 grams of mass. And then we have our baking soda and water solution, which actually looks oversaturated because there's a little extra baking soda. Remember how baking soda is not very soluble, but that's okay for the purposes of this investigation. So we're going to weigh it, and it is 56 grams. So we have 56 grams here. Not that much, I just put a bunch of weight on it, which is why it went all over the place. 56 grams here. 54 grams here. So do some quick math. What would the combined mass of these two solutions equal? If our baking soda is 56 grams, baking soda and water, if our calcium chloride and water is 54 grams, what would be the combined weight? What would be the mass total of these two solutions? Because what we're going to do is we're going to put them together. We're going to watch the reaction. We're going to see what happens. And here we go. Baking soda. I'm going to pour the calcium chloride into the baking soda. And then I'm going to give it a stir. Ready? I like this one because it takes a second. But here we go. We're moving now. A little bit less of a reaction. Does anybody know why? There's a little bit less of a reaction going on. Can anyone think of why there's less of a reaction, a little bit, it's less volatile of a reaction, but still a reaction? As you can, I'll get my mic close so you can hear all the bubbles, but not stick my face over it, so I'm getting carbon dioxide on my face. Let me give it a stir. There we go. Why would there be a less dramatic reaction with this one than we saw last week? Can anyone think? Ooh, nice. Ava in the chat. Yeah, there's more water, right? Last time we put 5 milliliters of calcium chloride, 5 milliliters of baking soda into 50 milliliters of water. This time, we have 100 milliliters of water. Twice as much water means that our solution is more diluted, right? It's less concentrated. So there's less stuff reacting or there's the same amount of stuff reacting in more of space. So it doesn't look as fancy. So a bunch of us said, okay, 110 grams. Let's take a look here. So if our conservation of mass is correct, we should see 110 grams on our scale. Let's take a look. We've got 109. So where the heck did that missing gram go? If we started with 110 grams of solution, and then when we combine them, now we have 109 grams. Where'd that missing gram go? It didn't just disappear. Where has it gone? Does anybody have a hypothesis as to where our missing gram has gone? It didn't just disappear. with mass, it can't be just destroyed out of nowhere or created out of nowhere, right? It's always got to go somewhere. Where the heck did that missing gram go? While you're pondering that, let me show you something else. So, just like with our citric acid and baking soda solution, I went ahead and I evaporated out this solution as well. Okay? Ooh, Ava has an idea that the missing gram got turned into heat. Interesting. It did turn into something. It's not heat. I went ahead and evaporated out this baking soda and calcium chloride solution. And I want us to take a look because something fascinating happened here. And actually, I'm going to grab this black piece of paper and put, so I can show it, and hopefully we'll be able to see a little bit more clearly. So, here's what was left. Oops, go that way. There we go. Here's what was left. So we've got that mystery white substance, that solid substance that formed. People were like, is it undissolved baking soda? And I think this confirms, as we evaporated it out, it's not undissolved baking soda. Otherwise, it would have more of this kind of puffy, almost looking like the stuff on your walls, the like popcorn ceilings or popcorn walls, right? Okay. And then also, don't those things look familiar? Oh, we have in the chat, kind of looks like salt. Let me grab our salt crystals again. See those squares going on? Believe it or not, it is salt. Sodium chloride was one of the products of this chemical reaction. In addition to that mystery white substance I talked about, right? I said it on last Friday's video. Okay, one of the other things, and that's where our precipitate comes into play. Let me pull up our word wall again so you can see what precipitate means. Down there at the bottom, zoop, a solid substance that forms as a product of a chemical reaction and settles out from a liquid. So we saw that layer, and I'm going to grab a solution that I did earlier. You can see that layer of white on the bottom. Will the black paper behind it do anything? Kind of. You can see that layer of white on the bottom that's a little less transparent. Okay, that's our precipitate. So that's a new solid material that was formed as the result of a chemical reaction. And that is calcium carbonate, otherwise known as chalk, which I thought was pretty cool. Calcium carbonate also found in things like eggshells, which is pretty cool. Excuse me, just for funsies, I'm going to go ahead and weigh this older one and see what's happened here. So this was we're still at, oh, look what's happened. We're down to 108. We've lost another gram. What is happening here? Where are our missing grams going? Let's see if this one that I poured probably an hour ago, is it any different? It's also at 108. It started at 111. So wait a minute. Now we lost another gram. Where did it go? We have to figure this out. Where did that other gram go? Think about what happened in this reaction. Besides the precipitate going to the bottom, what other thing happened here? What other evidence did we have of this reaction besides the precipitate? Just like our citric acid baking soda solution, we had a gas coming off. We had bubbles. We had carbon dioxide. That carbon dioxide has mass. Even though it's a gas and it's, incorporating itself with the air, it still has mass. That gas has mass. Y'all, that gas has mass. Okay? And we can safely say, because this started at 110, now it's down to 108. How many grams of carbon dioxide have been created and have fully separated itself from the rest of the solution, right? 2 grams. 2 whole grams of carbon dioxide have been made. Unbelievable. So this baking soda calcium chloride reaction is pretty cool because 3 things happened here. 1, we had some gas. We had carbon dioxide gas. 2, we had calcium carbonate. We had that mystery white precipitate floating down there at the bottom. And then 3, we also had some salt. And we can see that in the crystals. Okay. And then one last thing. I've got some precipitate here from an older solution I did earlier. One cool thing about calcium carbonate, it'll also react. And it'll react with vinegar. So I'm going to pour some vinegar in with our calcium carbonate. We're going to see what happens. Ooh, that vinegar is vinegary. I'm using cider vinegar, which is white vinegar would be a little stronger, but it's the only vinegar I had available. So we're going to see. Ready? And as you can see in here, we got more bubbles. So it's reacting again. Now, is it going to go back to being calcium chloride? No. It's going to react with the vinegar and become some other material, some other substance altogether. There we go. All right, everybody. Thank you. This was fun. Thinking about chemical reactions, turning stuff into new stuff. That's amazing. Using chemistry to make new things, right? There are innumerable other chemical reactions out there. Some chemical reactions cause a color change where you will add 2 substances together and all of a sudden that combination will turn blue or turn red or change color from green to blue or red to blue, right? There can be reactions, like we've seen with elephant toothpaste, right, that are exothermic. They give off heat as part of that reaction. There's an energy transfer in addition to those chemical reactions, right? Amazing stuff, this chemistry. All right, thank you for tuning in, everybody. Go ahead, fill out that exit ticket as best you can. On Friday, remember, we've got our baking soda, we've got our citric acid, we've got our calcium chloride. We've seen what they do when they interact with one another, but what happens when we put all 3 in one solution? Will a chemical reaction occur? Will the same compounds, the same products be made from these reactants? Or will something completely new be made from these reactants? You'll have to tune in on Friday at 12:30 to find out. Thank you, everybody, for tuning in. Have a good rest of the day, and we'll see you soon.